Hey everybody, it's Silvershroom, and welcome back to the Blender Solar System. Last time, we put together the systems of the ice giants Uranus and Neptune. And now, we're going to do the same for the solar system's dwarf planets, and unofficial dwarf planets. So anyway, just like before, I copy and paste the orbits. And now, gotta put them all in their proper collections. And from here, it's gonna be a lot of the same stuff, but since we don't have that much information on the dwarf planets, it's going to be slightly different. But just like before, I'm gonna clear the rotation of this orbit. And take the sun I have for Ceres, and have to follow this path. And then, do just like I did before, to orient the orbit correctly. And with Ceres, just need that right ascension and axial tilt. And its rotation period of just over 9 hours. And there we go. Pretty straightforward for Ceres. No moons. Just the largest object in the asteroid belt. So moving on, it's the unofficial dwarf planet Orcas. I'll clear that rotation again. That. And there we go, got the sun there. Over 280 years to orbit the sun. Much further out than Ceres. But unlike Ceres, it just so happens that Orcas has a moon, Vance. Now, unlike the other moons I've done so far, for whatever reason, the info I have is relative to the equator of the Earth. And there's nothing about the precession of its orbital nodes or anything, so I'm just going to do a regular orbit. Switch direction. Going to make the orbit itself the same way. That is, it going to act up again? No, it didn't that time, but whatever. Not much eccentricity. Now, in order to make this accurate, this can go ahead and follow the path that I didn't bother naming yet. So in order to make this accurate, I need to align it with Earth's equator relative to Orcas' orbit, which is going to be a bit complicated, but I can pull this off to the best of my ability by taking the longitude of Orcas' ascending node, its orbit. Then with the inclination, I do positive instead of negative like usual. And that should align it, with Earth's orbital plane. And now, I put this in but negative to try and get this x-axis back aligned as well as I can. And now, I do this 23.5 degrees axial tilt, and that should be aligned with Earth's equator. And now, I can put in the info I have for Vanth's orbit, longitude of the ascending node, inclination, and argument of periapsis. And we don't actually have, and I wasn't able to find accurate information on Orcas' axial tilt, but it is generally believed to be aligned with Vanth's orbit, so I'm just gonna copy that rotation. And I believe Orcas' rotation period is contested, but I believe to be about 10.5 hours. But because, as you can see, its north pole is pointed towards the sun, and consequently towards Earth in the present day, its rotation is hard to determine. Vanth, on the other hand, is widely believed to be synchronous, so we just need to put in its orbital period, which I didn't put into the orbit itself, but that's no problem. Just orbit about 9.5 days. Inclination, about 90 degrees mean anomaly, and forget about the precession. That'll take care of that. I guess it doesn't really, since I don't even have a real map of Vanth on there, it doesn't really matter which side is facing Orcas, but yeah, I'm not gonna bother with that. You can just rotate and have a synchronous rotation. The y-axis is approximately pointed towards Orcas, and it should stay that way. So Vanth is generally believed to be synchronous, but like I said, Orcas' rotation period is not certain. They believe that if it's not 10.5 hours, it may be mutually tidally locked to Vanth as Pluto is to Sharon. But also, because Vanth and Orcas are close in size, the barycenter between the system is outside Orcas. So we can mess with that a little, the same way we did with Earth and the Moon. We can shrink its orbit, scale its orbit down by that amount, and have Orcas copy the location of that Vanth empty object, accept invert, and scale the influence down. And you can see how Orcas and Vanth appear to orbit each other. Okay, now moving on to the dwarf planet, we do have quite a bit of extensive information on Pluto. I'll also give you a glimpse of Orcas and Vanth, though we don't know what they actually look like. But we do know what Pluto looks like thanks to New Horizons. And I'm going to do the same thing with its orbit. Okay, it's over there. Now, Pluto, like Uranus and evidently Orcas, is known for rotating on its side. Right ascension. And that is not the right direction. There we go. And a rotation period of just under 6.5 days. And that'll do it. Now, I do actually have information on the precession of their nodes and periapsis points, so what I'm going to do with Pluto's moons is going to be more akin to what I did with the moons of the planets. We've got Sharon, oh, you've got to be kidding me. Now, Styx. And Nyx. which I have actually with an eccentricity of 0, and even just copying and pasting that still glitches out. Why? Kerberos, also, I got here with an eccentricity of 0. And finally, Hydra. You know, there's probably ways I can make this process even easier with scripts, but too late now, I guess. Whatever. Okay, so let's get all these on their proper orbits. And now, orienting the orbits is going to work pretty much the same way. Okay, so first Sharon, and I'll just get through all of these. Okay, that's done. And now, to make them rotate and put in the orbit scripts. And some of them actually don't have precession periods for, so I'm just going to leave them as is. Okay, that's done. And now we can look at these. And see them orbit. And now a little extra to be done with Sharon. Let's copy the rotation of its orbit. Mean anomaly. And I believe it's the y-axis that I want to be facing that. Facing Pluto. And I should not put this driver in yet because I also need the y-axis of Pluto to be facing Sharon, and I'm going to need more than just the mean anomaly. I think I'm going to need the argument of periapsis and longitude the ascending node as well. And that should do it. And let's paste that driver in there. And Sharon's should be the same. And now you can see that Pluto and Sharon keep the same face to each other. But just like with Orcas and Vanth, we can take it one step further. Messing with the scale. Getting the Pluto to cut this, invert, and scale down the influence. And we're done. Now for the rest of these, it's going to be more of the same thing. Let me just finish this up. Now for the rest of the moons, I believe they're pretty much all I believe the info I have is pretty much all with respect to the ecliptic plane, which is Earth's orbital plane. So you can keep that in mind if you want to. Now, Haumea actually have the right ascension and declination of Haumea's North Pole. So in order to pull this off, I'm going to need to get it aligned with Earth's orbital plane. And I'll go ahead and do that to the orbits as well. Never quite perfect. Oh, wait. Okay, yeah, I need to tilt it by Earth's axial tilt 2. Then use the right ascension and declination. That's the North Pole, so it needs to go like 90 degrees plus another 13. Yeah. Lying on its side. Then extremely fast rotation, which is the reason for its odd shape. And evidently its ring actually rotates 3 times for every orbit of for every rotation of Haumea itself, and since it's parented, I kinda have to mess with it a little. This should achieve the desired effect. Not that it matters much, since the ring is just a uniform material. So anyway, let's quickly take care of its moons, which should, at this point in time, be aligned with the ecliptic plane. And I never made them the right size. And you gonna act up? Of course you are. Okay. Now let's do this. Okay. Almost done here. And Hayaka's rotation period apparently is known to be about 10 hours. So I guess I can do this. But what's important is their orbits, and that works out quite nicely. Next up, Quawar. Orbit. And its moon, Waywat. Come on. Okay. Now let's do what we did before. And because Quawar's axial tilt is unclear, I'll just copy the rotation of Waywat's orbit and throw in its rotation period of about 9 hours. And Waywat needs to orbit in about 12.5 days. I don't actually have a value for its mean anomaly, so just start at 0. And that takes care of that. Time for Maki Maki. Almost done. This is MK2's orbit. Maki's moon doesn't even have a name. Hardly any information on it whatsoever, though Blender's still going to act up. Don't even know how it's inclined. It's likely edge on with Maki's orbit because they suspect it was lost in Maki's glare, and that's why it wasn't discovered until recently. So I'll just leave Maki like this. It's about 23 hours to rotate. And we are good for... No, we're not. MK2 rotates in about 12.5 days. Anything else? 0. Wait a minute. And that's supposed to be orbit, not rotate. Perfect. Just 3 more to go. Gong Gong. And its moon, Shanglu. I'm way too proud of myself for being able to pronounce that. Once again, deal with the orbit. Here's Shanglu's orbit. I'm going to go ahead and put in the orbit now, because why not? And it orbits in just over 25 days. I believe that at the moment there are actually 2 fits for Shanglu's orbit, one prograde and one retrograde. Who knows for sure? I don't have mean anomaly. Am I missing something? No, it should start at 0 because I set the mean anomaly to 0. Yeah, it's working just fine. Now, you go like this. Blender. I love you, but why? Quite the eccentric orbit. And now, gotta deal with getting aligned with Earth's orbit. Now just a little bit of this. around as we're unsure of Gong's axial tilt. Let's just copy. Gong rotates in about 22.5 hours. Shanglu, we're not sure about though. Okay. 2 more. On to Heiress. As well as Dysnomia, the last moon to do. What? No, that's not supposed to go there. This is supposed to go there. Dysnomia. Let's scale that up. Now orbits in almost 16 days. And now for the last time, onto the ecliptic plane. And before we go any further, Heiress actually want aligned with the ecliptic as well. Let's finish up with Dysnomia. Dysnomia's good. Not entirely sure of its rotation, so I'll leave it. Heiress, Heiress actually has barely known axial tilt, but I want it to align it with Dysnomia's orbit, so I probably should have waited before copying the rotation. .78 degrees. Wait a minute. other way. Okay. And Heiress takes about 14.5 days to rotate. I swear that value was much smaller recently, but things change, we discover new stuff, yada yada yada. Yeah. And we are good for Heiress and Dysnomia. And last but not least, the distant Sedna. Dealing with its orbit one last time. Its extremely eccentric orbit. Set this on the path. And Sedna, no idea if it's axial tilt. All it takes is a little of this. And we are finally done. Next time on the Blender Solar System, we're going to put together the entire solar system. See you then.